That's first class stuff.
Whoop.
Computer science.
Smack that. Yeah. So which side are you standing at or trying to capture your image there? Maybe
Yeah.
this way?
I have to walk around, unfortunately. this is
I'd
fun.
say, yeah,
This is
do
good.
do what's comfortable for you.
Right.
Yeah, this oops. Does that looks good? This side.
That's good.
I mean, we have the audio capture on
Right.
the screen, so I wouldn't just do what's comfortable.
That's good. I'll try to stay within range. Right. Is there a clicker or something? I got one. Does work.
Okay, all right. I'll go over it. Thanks everyone for joining us. Welcome to the System Engineering and Operations Research Seminar. So our speaker today is Wang, and he is a Global Engineering Fellow at BAE Systems. He's the Chief Engineer for its Integrated Defense Solution Systems business. He's been actively engaged in a lot of areas that are of interest to us: system engineering, particularly model-based systems engineering, engineering management, cost estimating, and analysis. He has over 25 years experience in complex systems development, software development, systems and enterprise architecture, modeling and simulation, multi-criteria decision-making methods, so all things that are close to our hearts. He's also a regular instructor within the company, so teaches some of this material as well. So he'll be talking today about various processes for reuse.
All right.
Give it over to you.
Thank you. Thank you so much. All right. So thank you for giving me this opportunity to talk to you. And I was asking John, what should I talk about? John said, talk whatever you feel like. So that's very, very generous. So this is the work that I've been doing with collaborating with some industry partners and academic partners over the past few years. So I thought this is a good topic, sort of in the heart of systems engineering. So I got a number of charts kind of pick and choose and collapse them together, so it's a bit of material. I want to make sure that you get the best of my time, and so this is my prepared talking point, right? So start with the problem and motivations while we're doing this, and a little bit on a reuse taxonomy, and then we'll talk about this thing called a Generalized Reuse Framework, and then a couple of applications, one in particular into cost estimation, and then from there and see how we can integrate with the model-based system engineering. Like I said, it's quite a few charts. I'm open, so we can cut short on some topics, and we can delve into deeper on some other topics as far as I can support it. Okay, so feel free to interrupt me, and better when we are interactive. All right. All right. So we all do reuse in our lives, right? We do reuse more so in our work, especially nowadays. Very few things we build from scratch. However, having said that, there are different kind of approach or attitude towards reuse. One of approach I call it an adhoc and opportunistic reuse, right? So what's the characteristics? Typically, you think in the context of a software developer, and he's trying to put a code together. A lot of information on the web. He does, search and discover. right? Find the good snippets and copy and paste it over, adapt into whatever the situation is, making necessary changes, and here it works. And typically it is very much kind of wedged into your application, hardware in. However, it's very convenient. If you want something done quickly, we can get something done quickly, right? But we tend to, thank you so much, we tend to run into problems a little bit later in particular, right? And so we spend the rest of the time dealing with those problems. One particular phenomenon is that this is something that is non-scalable, right? So you can't really do much else other than this particular application you started off with. So, what happened is that if you want to extend it, expand it, you do a lot of what's known as refactoring, software refactoring, or even hardware refactoring. That's even more expensive. So, so that's one way of doing things. I think we've seen that a lot, and especially if you're a graduate student, I'm sure you have first-hand knowledge of that, right? Another way is more of what I call a planned or strategic reuse. This has to do with a strategy over a product line, right? Understand the portfolio, where the technology roadmap will lead you to, and it requires explicit process, standards, and more importantly, involves investment decisions, especially in a corporation framework. We spend a lot of time talking about how to invest in particular capability that enable a set of products or services, right? So greater degree reuse and tend to be more scalable and extensible. One of the particular application is a product line engineering. I'm sure some of you are familiar with. Really, the motivation behind it is really for later in life, in the life cycle, this notion of a reduction in cycle time and cost saving is very important, right? We've seen some examples over here. Big corporations, especially product companies, they put a great amount of thinking into how to do strategic reuse, right? So a little contrast between the two approaches. One is to search and discover in the sort of ad hoc and opportunistic reuse, and we get something, we'll modify what's necessary, adapt to the current application problems, fix it later, right? And the other way is more of a strategy, has to do with the tech roadmap, has to do with the planning coordination, more importantly, investment decisions, right? And this is where company put its own few dollars, hard-earned dollars into work for enable future products, right? More of a case-by-case for opportunistic reuse requires the individual knowledge and how agile you are. Really, it's good for more of a low level, implementation level, smaller scale components, reuse. So what I call this is more of a summarized effort, right? Individual efforts. And the other one is more of a one-to-many. You want to invest once, enable many applications, requires more product knowledge, product know-how, corporate knowledge. That's for large-scale product line situations. So I, compare that to as a team sport, right? It's more team sport. You got centrally, draw back and pass it. Someone else catches the ball down the road. A couple of words about product line engineering. I'm sure we understand that basic concept, right? My early time as a software, by the way, I grew up as a software developer and developed mission apps. We did this a lot. I actually got some of my knowledge, based on that practical experience. if you have a product line, you always have some sort of trunk, basic product, and you have a branches. It's known as a variants in product engineering, right? Essentially inherit the basic characteristic of product line. However, each has its own applications. The idea is that if we plan it right, some of the features and capabilities developed in one branch can be applied to others if we plan it right. We typically do this, split and merge exercise. So effectively institutionalizing core product capabilities, right? And you see a lot of commercial examples, right? Really, the product lines, most of the key features and capability, they're 9% the same. There's special variants appeal to a particular application, right? So what's the motivation here, right? So traditional focus, are we talking about reuse that people are doing reuse for years, right? But more so on the leverage side, they're thinking about how can I get something that I can reuse the benefit in my current project. Less so on the strategic side, how can we actually plan and invest, do strategic invest to benefit later in the life cycle. I think that is what we're trying to hit. The inherent assumption is that there is something you can use when you need it, which may not be the case, right? The product decision makers must consider the cost of leveraging. In fact, when you leverage is not necessarily free, your sort of intuitive mind and say, okay, well, this is something I can just pick up and put it in and work. It doesn't work that way. There's a cost of leveraging, and more importantly, really how we do investment decisions into product line decisions, right? So the goal has been, we try to have an industry agreed framework, mostly benefit these strategic decisions that enable corporations, ones like ours, make decisions in a project and product context. Make sense? All right, so what can we actually reuse? It's a little bit of back to the basics, right? So we reuse the whole system, we use a part of the system, we use some of the design artifact, reuse the design artifacts potentially. We know we reuse source of code, source line of code, especially with the open source community, right? Another approach is to look at the system from two perspectives, right? One is more of a component view. That's, you talk about architecture. What is architecture? It's the pieces connect together into larger pieces. Fundamentally, that's what architecture is, right? There's another view. It's more of a functional view. Essentially, a system consists of a set of features and functionalities, and in collection, achieve some sort of mission objective, right? That's looking at not so much from bits and pieces, how they string or collapse together, but more of what is the fundamental features, right? So it's a notion of the bill of features. I think recently being emerged and been talked about in the industry, mostly in the product line kind of environment. So the idea is, this is the idea. I put a little bit of taxonomy, you can see it, over here and says, what's a system? Essentially, from a features functionality point of view, a system consists of one or more set of features, right? So what's a feature? Feature essentially has, you can kind of describe it into two perspectives. One's the system features, right? Essentially is whatever the brake motor thing is made out of the system. At the end of the day, when they become operational, they would deliver a set of functionality. So it consists, it's in the sort of forms of either structure, or the interfaces between the structure, or importantly, it's functions. Functions in terms of, control logics, workflows, or algorithms, right? If you think about system, you step back, that's essentially what the operational system is about, On the other hand, are design attributes, right? Design attributes essentially say, hey, in order to build a system like this, I need to have do some work and create some other stuff that kind of represent the system that ultimately I'm going to build. So fundamentally, what they come in the shape and forms? They come in requirements, and come in some sort of various forms of models, right? From a descriptive model to analytic models to model simulation kind of models into mechanical drawings, for example. There are models, right, of different forms. Specs, right? Written specs as well as data, many different type of form data. So really, this is a representation of the operational system, especially nowadays you think in terms of digital thread and digital twins. And one could argue say all of them is a part of the system, right? And the other notion is the artifacts, right? In fact, I'm part of NDIA Dixie Week, Digital Engineering Information Exchange Working Group sponsored by OSD, by Phil Zimmerman. In that forum, we had a lot of debates on what's an artifact, what's the digital artifacts, and we still haven't made up our mind. Too many people trying to define it. But it's interesting. I learned from some professor years ago. Artifact actually is made up two words: art and fact. Essentially, is the fact that's embodied in the art form. That's a pretty good explanation, right? Right. And so, really, how do you capture features? You use artifacts, and therefore, system features are embodied into system artifacts. Therefore, that is, at the end of the day, how we reuse these feature and functionalities, right? So here's an example of this taxonomy in terms of a system lifecycle, right? So I consider integrated system essentially realized by assembling a set of artifacts, system artifacts, right? And over life cycle, at different maturity, we assemble different kind of artifacts, from potentially a drawing on the back of a napkin all the way elaborate into an end system, right? At different stages, the system, you have different kind of things that's features embodied into artifacts you potentially could use or reuse, right? So we reuse these artifacts. We realize a system essentially by a careful pick and choose a unique set of system artifacts and mature them over time, right? So by life cycle, you can see these are different examples that what kind of things you potentially could reuse, right? So, but still, it's a huge challenge, right? How do you manage this environment? There's so many things. How do you manage this environment, right? So here is the proposal, I put forth in the past few years. It's called a Generalized Reuse Framework. You can see later I'll tell you how it evolved into this. So essentially defines the interactive set two processes. One of it is I call it develop for reuse. On the other side, develop with reuse. The idea is develop for reuse is those activities that produce reusable artifacts that are intended for later leverage in the system or other systems, right? The focus is more on strategic planning and the investment decisions for a system life cycle or future benefits. With the reuse, it focuses on leveraging the reusable artifacts, right? And really the motivation is cycle time reduction and cost reduction. More cycle time reduction, so that's more important. That's another discussion. But the important point is the two processes are not siloed, not standalone, they are interactive, and that's why this framework works together only if the two processes can work together, right? So, notion is this. You think a context of project scope, that we're doing project from get-go in this form of contract, right? From a planner point of view, the project consists of two scopes. One is the DWR, so we're trying to realize the current deliverable with the benefit of reuse. But there's another content to say, within the same project scope, I can do more for DFR. So therefore, the whole overall project scope becomes the sum of the two. And here's the perspective, right? It's the same, the notion is the same product or product line mature over time. So as the development, so this is a article or delivery or release, think of that way. The first one, you would do more in DFR, so development for reuse, less so on the DWR, but as the number of articles increase or the releases matures, the relative contents of with reuse increases relative to for reuse, and you started reaping in the benefit of the investment, right? So that's the notion. That's from a product line life cycle perspective. If we plan it right, you would have this relative comparison reuse for reuse, and the notion is the overall cost, life cycle cost would reduce. That's the notion, right? So here's the framework. We define a set of categories in terms of development activities, right? So from a life cycle investment for reuse, well, there's always category that you don't have that consideration. You know, a lot of them just do not, right? You have this idea of conceptualized for reuse, okay? The next level down is designed for reuse, constructed for reuse, and validated for reuse. These are the 5 categories you can see implied by the words. The one is more mature than the one before it. On the other side, the DWR, the with reuse side, you would have something new, which you don't have anything to benefit from. Therefore, it's a new development, right? You're gonna start clean slate. There's the design modified, design implemented, adopted for integration, adapted for integration, adopted for integration, and managed. You know, lots of words. I'll pivot it down to the next layer to explain it, right? For reuse, development for reuse. These are the sort of a high-level conceptual definitions, right? So if there's no DFR, you don't have any required activity, there's nothing really come out. If there's anything, it'll be accidental in terms of reusable artifacts. Conceptualized reuse, which requires you've done system analysis, you have done the architecture development at a logical level, right? So function logic architecture is what that process would deliver. Again, these are in the form of reuse artifacts. Design for reuse, you know, essentially you think about baselines. This is a design baseline. Not only we have done the analysis architecture, but we're actually doing the physical design. We've done that. Really, the physical design of the system has been completed, right, which you can potentially use as a reusable artifact. Constructed for reuse is something that has been implemented, has been unit tested as a component or module or something, or assembly or something. All right, so it's implemented or verified system components. validated for reuse is something not only have you implemented, but you have really implemented in the end system that's been validated. Typically requires the system being in an operational scenario, validating in an actual operational environment, something that has the highest level of maturity, right? So a way of thinking of this is in terms of system V, right? So we start from here, from a concept, and if you exit at the requirement architecture level, the hope is if you down the right, the artifacts will be at the level of conceptualized reuse. And if you exit at the level of the physical designs, and you would end up with the artifacts that can be used for design for reuse, so on and so forth, especially when you have system in operational environments that validated in operations, those will have the maturity of validated for reuse, okay? So on the other side, this is the with the reuse concept, right? So in terms of categories, so if I can benefit something like this, what will be the required effort to the complete of my development cycle, right? If it's new, let's start from new. You got to go through everything, right? If it's design modified, so keep in mind we're trying to leverage the logical and functional architecture. So this is where you have to complete your design at the physical level and then implement it and test and verify it, right? Design implemented, essentially say I can take something that's complete in design, in my next phase will be implementation or build to print at that level of reuse, right? So you're leveraging the physical design of the system and adaptive for reuse. This is tricky, is in the continuum and say, okay, there's something that I can reuse is being implemented, but I may have to adapt this to fit into my current application. Typically, the activity required is you may have to modify interfaces, right? But not the guts. So we're still using whatever the functionality it provides, but it doesn't fit in my environment, therefore I had to change interfaces to sort of adapt into the environment. Adopted is more of a reuse in the black box level. I can reuse it. Typically something that developed in the previous life cycle. However, I still need to do integration, more importantly, complete V&V life cycle, okay? And so this is for adopted. Managed is the interesting phenomenon in the industry. We had a lot of debates over that, is that essentially this is something that you either developed in previous increments or articles, releases. I'm carrying it with me. But the engineering effort is not zero. It requires a technical management effort. Even with something you inherit, you know it's working from a previous release, and also requires a lightweight V&V activity, at least requires level inspection. You need to account for something, right? Making sure everything is still there. You may have to run through some regression tests without modification. That's called management. Another scenario for manage is this. In the industry, we do teamwork. In other words, prime-sub relationship, right? So if I'm the prime, I sub this requirement to John, who is responsible for bringing the system pieces in, plug and play, right? So you are responsible for all the requirement, realization, responsibility at V&V. You actually come in, making sure it's working with a larger system. As a prime, it's still not free. I need to manage that interface. You see, that's what the manage is about. And that is a very common use of the managed category, right? It doesn't mean that we just all of a sudden sort of right away, right on his cost. He still has a cost within the even contract, right? You see, but it's what the costs incur in the prime level. Okay, so these are the sort of 6 categories, right? Again, the notion is that each of one of these you can start leveraging in sort of in a later life cycle because the artifacts you leveraging are more mature. So you enable to skip some early steps in the life cycle, right? So conceptually, you can conceptualize in that way, right? So as you can see, it's an activity-based model. This generalized reuse framework. Essentially, we're saying that, with the increasing maturity in the investment, you need to put in more effort. That's cost. On the other side, you have a decreasing amount of cost incurred when you are able to leverage. So in other words, you invest more, you'll be able to leverage more. That requires more cost in investment, less cost on the leverage side. Well, you say, well, why? What does that get me, right? I'm going to spend that anyway, but keep in mind the development of reuse is for the context, in the context of that one-to-many kind of applications. In other words, I'd like to invest in key technology that's a core of my product line that'll apply to different variants of my product. So there's a one-to-many. So collectively, you are saving cost. Not only that, cycle time reduction is very critical. That gets you to the time to market, right? So overall, it's still very beneficial exercise, right? But it is an activity-based model. All the categories, things in terms of activities involved in the respective processes, right? Right. So this is a sort of a view to look at how we would plan for an interactive process like that, right? So on one side, you have a DFR effort. On the other side, you have the DWR effort, right? If you say, okay, I want to do design for reuse, right? And so what would you be able to leverage in your ultimate implementation? That means typically I can leverage at the design implemented level. But if I say, okay, I can't, for whatever reason, go to that level, I can only do conceptualized reuse, which you end up on the other side, all you could do is leverage a logical and functional architecture, and therefore the effort to realize that reusable artifact is at the level of design modified. So gives you that kind of sort of use case for you make decisions, right? This is captured in this kind of use case diagram in here, essentially, and say, hey, in the ultimate case, if my DFR would actually develop a part of the system to the maturity of validated for reuse, on the DFR side, the effort that we incur will be managed, right? If you can't do that, you may be able to find opportunity for constructive for reuse. In this case, you see if a tailoring is required, therefore you would incur adaptive for reuse, and if it's only integration is required, on the other you can say I can leverage at the level of adopted for integration, right? Similarly, if I would have to go down design for reuse, in the leverage on the DWR side, would say, hey, is it the same functionality I leverage, right? Is it the same? If exactly the same, then I would do the design implement, essentially build a print based on specs. If I had to change some part of it, I need to go to design modified, right? Design modified. And again, if you haven't put any efforts in here, chances are you back to the square one, you gotta do new. So that is the relationship between the two processes. Does that make sense? Yeah. Okay, so that was about the generalized reuse framework from a theoretical point of view. This is how I constructed it. You know, it's a sort of agreement with the industry group. Do you have questions or comments to this point? Okay.
Do you have any examples of
Yeah.
applications where this has been used, or
Right.
how does it impact? How do you use the framework to make a decision about
Excellent.
whether you would use it?
So you just set the stage for the next topic. Excellent. So this, I'm going to talk to next talk to you about application of use of this framework, right? In cost estimating, right? And there's some references that have to do with this particular application. We did this with a industry model called a CoSystem Model. Have you heard of CoSystem Model or familiarized? I know Art is. The rest of you, have you heard of CoSystem Model?
We teach that in our, let's say, courses.
Oh, you do? Okay, excellent, excellent. Yeah. And then, of course, you know Kokomo, right? So it's a part of that Kokomo family. Stands for Constructed System Engineering Cost Model. Nobody knows how to today what it stands for. CoSystem Model actually is a better name. So essentially it's a parametric model for system engineering. Again, for a product development context. It covers the full system lifecycle. It was developed originally by Dr. right now Professor Ricardo Verlerdi, and he was this was his PhD dissertation on the Barry Bean, Professor Barry Bean in USC. More importantly, this effort was done by the industry, sort of supported by the industry consortium with various commercial companies, mostly aerospace industry and other academic entities, etc. Right? And this entity is called CSSE under Barry Bean, Center for System Software Engineering at the USC. And so this is the context of it. You know, Kokomo has been there for a long time, one or two. There was in early 2000 when Ricardo was studying, he was looking at, there was a discussion at the industry level. There's really nothing for systems engineering. Most of the estimation is either hardware-centric or software-centric. That was the sort of catalyst to get this work started, and it actually took off. This is a black box view or conceptual view of this model, right? So the idea is that, like anything else, with estimation, you need to size it first, right? In software, I'm sure if you teach this, you will know the basic site driver is lines of code, right? Source lines of code. In system, in this model, we defined there are 4 site drivers in terms of counts. Number of system requirement, number of system interfaces, number of operational scenarios, and number of critical algorithms, right? Easier said than done. There's actually specific definition of what they mean, as well as accounting rules are. And then additionally, there are about 14 cost drivers. Essentially captures the product and project environment. Say, hey, do you really know the system requirement really well? Or do you really familiar with architecture? A lot of risk or not so much risk. And these are more of a qualitative kind of assessment of the project environment. So these are the input to this model. And with the historical calibration, like any other cost model, you get an effort output in terms of person month or person hours for a project. So that's the basic black box view of this model, right? So little history, When I first sort of developed Ricardo Pavlov's dissertation, it was great, a lot of interest in the industry, but I'll show you a little later, give you a little more details. The first version was published about 2005, and there was a lot of interest. People started try to use it in the industry, including myself, and for my enterprise. And very quickly, we find out it wasn't really usable. It's a great theoretical framework, but doesn't really capture the real environment. You get an estimate. It's just complete out of whack, right? It just it's not. It's a hard effort for a PhD student dissertation. The framework is great, but it's not usable. One of the fundamental problems that I found was that it has an innate fundamental assumption that everything we do is brand new. We start from a clean slate. That was the fundamental philosophy behind that, right? So obviously that's not true. In fact, 90% or maybe even more percent of the work that we do, especially we do 100%, there's nothing new. There's no new development. So that sort of inspired some of us looking into creating a reuse model for it. So that's how it started. And long story short, we had a partial reuse model created. Okay, essentially the DWR portion is in slightly different variants. And at the end of that journey, we actually made it a PhD student, Hearten, who documented this in his dissertation. And that sort of culminated into a CoSystem Model 2.0 under BAE. And then we continued to work on it between the last about 6-7 years. We come to agreement of Generalized Reuse Framework, which is culminated into a 3.0, yet another PhD student that graduated last year, and Jim Alstead, again under Barry Beam and some other professors in the USC, right? We help them out. So this is the way you can see the industry consortium work. We help them sort of distill the knowledge together, produce PhD at the same time, which is a good thing, right? Right. So let's go into kind of gray box view of the CoSystem model. So, if you teach that, you know this, right? This is the fundamental form, right? So in other words, the person hours, or effort hours, is equal to a big constant multiplied by a quantity called a system size, and that raise up to the exponent, so it's nonlinear. And last factor is a compound factor called the composite effort multiplier, right? So this system size encapsulates those 4 fundamental site drivers. Remember, requirements, interfaces, algorithms, and scenarios. This CEM right here, composite multiplier, that sort of captures all the other 14 drivers, cost drivers. We call it complexity factors, right? So what are those 4 site drivers? Again, number of system requirement, number of system interfaces, number of critical algorithms, and number of operational scenarios, right? And they collectively made up this quantity called a system size. This is a parametric relationship. Because of the fact that we all say, well, no, I heard that not all requirements are created equal, each one of them are scaled or weighted by 2 sets of factors, 2-dimensional. One is level complexity, and the other is categories of reuse. And that's the connection right here. So levels of complexity, this is the original CoSystem model. So given the requirement, they could come in the form of easy, nominal, or difficult, right? Again, there are four-side driver, there's a weight, there's a whole host of work that put into this kind of coefficients skill set based on the industry Delphi. Degrees reuse is essentially adopts the generalized reuse framework of these two sets of processes, all right? So if you look at 1.0 form, essentially it says my effort is equal to that big coefficient multiplied by this thing altogether, right? So these defines represents requirements, interfaces, algorithms, and scenarios. They comes into three flavors, right? Easy, nominal, and difficult, and sum over those three categories across the four drivers, and this whole thing is the system size, right? And that captures the size of work gotta do. And then that got raised to exponent and multiplied by this product of the 14 driver. That was the original form. The notion is that through historical calibration, you determine for your company, organization, product line, you determine the coefficients here and exponent here. Right? That's through data calibration, looking at the typical calibration process. Right? So that's 1.0. You can see there's no reuse consideration here, right? So the 2.0 was kind of partial reuse model. Essentially, is saying, okay, the project effort consists of a wide spectrum of reuse efforts. So it comes in this form, right? In other words, the inner guts are still the same. The four drivers, right? That's the K enumerates to, comes in easy, normal, difficult, except there's yet another coefficient that captures these 6 reuse categories, right? Again, you sum it up, right? Same thing, you raise it to exponent and calibrate it into a big productivity constant. And there was a separate set of work dealing with this. I'm not gonna get there, right? We did a lot of work on that. So you can see this is a partial reuse, right? We talk about leveraging. You can see these categories. With the exception of this category, because we didn't really know what to do with it, but I had to make, Jared has to graduate. So we made this sort of not so ideal kind of arrangement. So he can get his PhD, which was good. And I continued on and said, that's not right. And so really the project effort is equal to the DWR effort versus plus the DFR effort. There you go. It gets slightly more complicated. So essentially the first term is the DWR effort, the second is the DFR effort, right? For each one of these, right, this is the DFR category sum up, the DWR's effort is summed up. Each respectively calibrate to set of productivity coefficients as well as exponent. And these are the categories that's summarized into R. Right? So that's how it comes together. Right? So now we have a complete consideration of a reuse. Right? I want to show you there is actually quantitative results that supports all these categories. And remember, there was a two-dimensional. This is the reuse dimension, and the other one was the other. It was the original calibration, but this is the DWR weights, right? Again, it culminates to 100% is new, right? And this is the relative weights against the 4 drivers, right? For requirement, interfaces, algorithms, and scenarios. That's how it works together, right? And this is the DFR part. Again, it's increasing effort, right? For each of these 4 drivers. How do we do that? I tell you, lots of work. So, I led a kind of 3 rounds of industry Delphi efforts in the forum of CSSE under USC, PSM, and in COSY. So we had a number of participants from different companies, academia, I think 1 or 2 government, I don't remember. There's a long list of participants. There's specific instruction. The way we did it is actually at the time, we used the EIA 632. And that is a predecessor to the ISO 15288. That, 632 defined about 33 engineering processes, technical processes mostly. And nowadays it's been wrapped into ISO 15288. There was talk, I think Gary said this time that they're going to revive it in some ways. I don't know. But it was very good. Very nice definition. Again, it's being absorbed into 15288. So what we did is say, hey, with those 5 process groups in 33 activities, we get stakeholders to rate. For each of the activities, you can rate the 4 requirements, interfaces, and algorithm scenarios, and see how they apply to activities apply to those, or reversely, is there any relevance of those 4 drivers in that particular activity? And they come back with a rating. So we went through a lot of workshops and talk about this is how you understand it, sort of anchor them to make sure that we don't, we don't go out of the ballpark too much. So there was a lot of that effort, yeah.
I just had time check, we have about 5 minutes.
Oh, about 5 minutes,
Yeah, so-
okay, very good, yeah. So, so that's how we got it and synthesized those rounds of Delphi's and got to those weights. All right, so that hopefully explains this one application, right? Since we only get 5 minutes, I'm gonna fly through the rest of it really quickly so you get a notion. So makes sense so far, right? This is one specific application. In fact, we have an implementation within our company of this model, the CoSystem. We actually implement a tool to use it for bidding and project estimation purposes. Right?
At BAE.
At BAE, yeah. We collected about close to 100 data points within. That's actually how it benefited Jim Allstead. He couldn't get any data, so couldn't graduate. So Barry said, "You come visit Gan for." So he came, spent multiple weeks with me and analyzed my data. So anyway, so that was the site. What we did is that when I presented this effort, and some guy from No Magic came to me and said, "Hey, this is very intriguing, right?" And I think there's a good opportunity that there is a natural connection between the Generalized Reuse Framework, especially in the context of CoSystem, and in system modeling under System L, right? So we did a bunch of work in the past couple of years, and actually we authored a few papers. The notion is this, right? Historically, you think about estimating and design. There are 2 different universes. the designers, the architects, and when they design a system, hardly they ever think about estimating. And these other guys who actually trying to cost analyze trying to cut cost, they have no clue where to start. And that's the historical divide. We're saying, hey, really, you actually share the same data. So that's the motivation behind it. Say, how can we connect closer? We call it a chasm between the two worlds, right? Really, it's the same set of data. So I'm going to go through this. The idea is this, right? So the CoSystem cost drivers, site drivers, are innately present in the SysML diagram. Become requirements, interfaces, algorithms, scenarios. They're there. You just need to capture them the right way. In fact, if you look at the 4 pillars of SysML, requirements, right? That's one pillar. Structure is another pillar, right? And behavior and the parametrics. They're all in a different, slightly different form of the same thing as in here, if you can map them correctly. And by the way we characterize these can be easily done in the SysML environment using the innate tool capability, the metric capability, right? So you understand the stereotypes in SysML, right? So we can create stereotypes within, let's say, magic draw to define these reuse categories and the complexity factors of the site driver, right? So if you think about these 2 dimensions, if you add them up, there are 4 site drivers come into 3 levels of difficulty and 6 levels of DWR and 5 levels of DFR. If you do the math, it comes to about over 130 different kind of flavors of groupings. It's a lot of work for anybody who's trying to do the work. And there's ways, this is a practical challenge. But if you leverage the stereotypes in SysML and use something called a profile, you can create a profile. This becomes really easy. Really easy. So the idea is that now the work that used to take 2 groups of people now can be done 1, right? System engineers, you still do the architecture definition. As you define it, you can identify your drivers, you can do the classification, and you leverage the metric capability within tool to do the reporting. All the administrative things. So they will gather the counts, calculate for you, and then you can export it, publish into a cost model. You get, if that integration is tight, you get cost instantaneously as you develop the architecture, right? So that's the idea, right? So this is where you do the system model, and this is where I'm saying, how do you map it? Algorithm, these are the candidates from which you identify them. Requirements, straightforward requirements, although there are caveats on what the requirements are. Interfaces, you look for ports, right? That's in the SysML. And then scenarios, you use use cases, right? For example, I mean, look at the BDD in here. You can literally start counting the ports, right? And then once you summarize them, all you need to do by apply the stereotypes is drop down menu and say, hey, I'll just add and say, what's this? This is adopted, or that is adapted, whatever it is. And you can just summarize them very quickly and use the magic tool. You push a button, boom, it's summarizing in the form, in the grids that the cost model require that you can do very quickly this round trip. That's what you're supposed to do, right, as an architect, right? Except we just can't do it. It's too hard so far. This makes it so much more easy. And that is the notion. So, so that's the work. Anyway, so like I said, didn't do justice, just flew by it, but hopefully we talked about the Generalized Reuse Framework for strategic planning, investment decisions, and specific application to parametric estimating with a CoSystem. It can apply to anything else. But that's the work we did with that. built into the fundamental, what's known as CR, cost estimation relationships. And from there, we push forward into a system level integration. And that's important to us. I think it's significant because this is where you extend your digital thread, not only in the design architecture space, but also in the economic space. Assess cost impact, do cost trades, etc. So with that, I ran over about
we started 10 minutes late. So time for a question or two. And are you able to join us for lunch?
Sure, I think so.
Okay,
Yeah.
so if anyone wants to join us for lunch, we'll also have opportunity for kind of more in-depth discussion.
Right.
One or two questions.
I have a question about design for reuse.
Mm-hmm.
In an environment, you seem to be talking about like an organization that is developing some kind of commercial product and they're making an investment and they're trying to make an investment in such a way that they can leverage that investment for future iterations of that product or a similar product. So, but what about a situation where I'm developing a system for a client? And this system this client would love if I could reuse stuff that I had done for previous clients, but doesn't want to pay for me to reuse stuff that I'm going to do to build something for a future that I can reuse for a future client.
Right.
How do you address that issue?
Yeah, that's a tough thing, right?
Mm-hmm.
Yeah, so nobody wants to pay more than you get, right? And this is where you got. First of all, I don't have an answer for that. Okay, just to be clear. Okay, but
just put it out there.
Yeah, but if there are two considerations, right? Even with that constraint, if I'm a smart manager, I can still apply this thought process in it. Ultimately, it is your decision, your team decision on how to realize your client stuff. As an engineer, we're not there just, moving widgets. There's creative work. There's always option you do one way versus the other. And there's a lot of, trade space or flexibilities on you approach this way. You don't have to be extensive, explicit efforts in to create a huge amount of cost, which wasn't part of the deliverable. But even at the subtle stage, you can say, if I approach this slightly more strategically, and then I can shape this part of my system more reusable, right? So that's one consideration. The other consideration is that you stepping back. Even in the contract environment, that's what we are in contract environment. We got our contract. We can do the work for customer. Is not because we look pretty or more muscular or something like that. It is we have some discriminators. We have certain strength that's stronger than competitors. And that didn't come for free. And that involves the corporate investment, which is not customer consideration. That is a corporate decision that said we want to develop this capability, becomes an enabler, a discriminator for us to win the contract, then we can apply for that. So that goes beyond the immediate scope of that particular contract execution. And even with that, as a project manager, project engineer manager, you need to be understanding of the strategy or product strategy, investment strategy of the company. You can't just do it in silo, right? Sometimes we do. So in that sense, it makes a lot of sense, a lot of connections in here, even though it is, for you, it doesn't really cost a lot, but for the corporation, it actually costs more because we like to enable your project and the project next to you. So that is kind of thought process, if that makes sense. Yeah.
Yeah, I think that's right on for an answer, right? It takes investment from the company. which, there's always competition for investment funds in the
Right.
company, and so you have to make the right argument.
Right.
But I've watched companies do that, right? They say we will invest this much money to enable something that we can use on multiple contracts.
Right.
It might be a tool set, it might not be reusable parts of the system.
Right.
It might be the tools that are used to build the system,
Right.
rather than building tools one at a time every time there's a new project.
Right.
Or it could be
Yeah,
better
so.
trackers or
yeah.
better, whatever it is
Right.
that they put together in their R&D, internal R&D, anticipating that would be used
Yeah.
for multiple.
For example, I'm managing the investment for my business unit, right, for my business area. We put in money, put a lot of money in cyber, right? On cybersecurity. We also put in a lot of money into autonomy. That's not just one project. If it's for one project, we're not going to do it because we perceive there's a huge market over there. There's a array of customers which we can leverage. So we will develop, for instance, the autopilot control mechanism, right? That's not something that is going to change from project A to project B. It's a fundamental capability that would go into multiple projects.
All right, well, I think, I'll wrap us up, and then if you'd like to ask a question afterwards, then
Okay.
we'll do that.
Right.
So thank you very much.
Right. Thank you.
We'll go over to Ike's. So, yeah, we'll head over to Ike's if anyone wants to join us. Let me know, and we'll probably meet downstairs in a few minutes.
So, 12:10, so what time?
12:20 we'll be downstairs.
Okay, I'll meet you in the lobby.